So let's get started. Thank you for coming on a Sunday. Okay, so the idea of this review is going over the demand and supply theory. You usually have two types of questions. Some questions are graphic, like this one, where you have a grid and you just follow the instructions, draw some lines, and answer the questions. Consumer surplus, equilibrium price, equilibrium quantities, etc. The other type of questions that we will see today too are questions with the formulas associated to the supply line and the demand line. And then you have to find the equilibrium with those formulas, etc. So we will do it both ways, okay? So let's start with this graphic question. The first question is, refer to this figure, supply and demand. If a price floor of 13 is imposed on this market, what is likely the effect? So, okay, first of all, we draw a line at 13, following the grid, right? Why is this a binding price floor? The idea of a price floor is that the price cannot go, the government thinks that the price shouldn't go below this line, right? Why? Because probably the equilibrium price is too low for the market conditions, right? And they decided to regulate it, and they put this price, right? Usually a price floor is binding when it is higher than the equilibrium price. Otherwise, it doesn't make sense because the equilibrium price is better, okay? Okay, so then the question asks you, what is likely to be the effect? What happens here? At this price, the supply function, the quantity supplied, is higher than the quantity demanded, right? What is that? Surplus, okay? So we are going to find a surplus. We find the quantities in the supply and the demand function associated with that price floor. In this case, because this graphic is very easy, here the quantity supplied is going to be 15 and the quantity demanded is going to be 8, okay? So the surplus here is 7 units. And my answer is A, okay? Is everyone with me? Good. Now, next question. The next question refers to the same graph and asks you, what is the consumer surplus in equilibrium? So first of all, let's think about what is the consumer surplus. The consumer surplus is the difference between the willingness to pay that is represented by what? What represents the willingness to pay of the consumers? The demand line, exactly. So demand is always associated with the willingness to pay of the consumers. And the supply function is associated with the cost of the producers, okay? So what the consumer surplus is telling me is the difference between the willingness to pay. What does this mean? That for these quantities, the willingness to pay of the consumer side is this price. For these quantities, the willingness to pay is this price, etc., okay? So the consumer surplus is, I find my equilibrium price, which in this case is 11, okay? And I have that there is this whole triangle here is giving me the consumer surplus. Is giving me the difference at each quantity between the willingness to pay on the consumer side and the actual equilibrium price. Is that clear? So you just have to find the area of this triangle. How do you find that? Either for a graph like this, I'm sorry, or in an equation, the way you think about it is the price of the demand function, this intercept here, which in this case is 17, minus the equilibrium price which in this case is 11, times the optimal quantities, which in this case are 12, and the area of a triangle is base times height divided by 2, okay? So this is the height, this is the base, and this I divided by 2, okay? So it's 17 minus 11 times 12 divided by 2. This is equal to 6 times 12 divided by 2. This is equal to 36. So my consumer surplus, the answer is C. Is that clear for everyone? Good? Okay.
Do you have a question to stop?
36 what? Who was? Okay. No. This third question is a little bit more involved. Why? Because it tells you, first, if there is a 7 per unit negative externality associated with the consumption of this good, what is the total surplus after the socially optimal tax is implemented? Yes?
What is negative externality?
Okay, I'm going to answer that. So he asked, what is a negative externality? So a negative externality is an extra cost that affects everyone, but you sort of don't see it, right? So, for example, a positive externality is that if you use a vaccine, right, then you are healthy. That is giving a positive externality to the people that surrounds you because you are not going to get the flu, for example, right? A negative externality is the person next to you that doesn't get the flu vaccine, right? So this person is generating a social cost for you because that person is more likely to get sick and is more likely to affect everyone else, okay? So in this case, a negative externality of 7 per unit is an extra cost for this market, okay? So what happens when there is a negative externality? The government intervenes. How can the government intervene? With a tax. So if there is a negative externality of 7, this means that this demand is incorporating an extra cost of 7 for everyone. And you don't want that, right? So what the government is saying is like, okay, I'm going to ask for a tax of 7, so everyone pays me that, and I see how I redistribute that to everyone, okay? That's what happens with the that I have. Okay, good. So this sounds tricky because you are combining externality with tax, but the important thing here is don't let the question trick you. And you offset the negative externality with a tax as a government. So now you just have to think about this as, okay, I am imposing a tax of 7 on this market, right? To get rid of that negative effect that this demand had, okay? So how do I do that? How do I impose a tax of 7? When you impose a tax, what you do is that you, in what you learn in this class, you shift either the supply or the demand function, the amount of the tax, okay? I always find it easy to shift the demand function because you just bring it down, but you can do it with the supply function. It's exactly the same. So you shift the demand function 7. You count 1, 2, 3, 4, 5, 6, 7. And And let's if I were a good drawer, this will be two parallel lines. I think. Okay. So I have shifted the demand, the amount of the tax. Okay? Everyone with me? To offset the effect of the negative externality, I shift the demand down, okay? Because the negative externality is just like costing these people more. Yes?
I get the X and I get the Y, but my question is how'd you get this 7 on this side?
The 7 on this side?
Yeah, how'd you
Oh,
find that line?
okay. You just like, usually when you get these examples with a grid, how you have to draw a parallel line. So either you count 7 from here or 7 from here. I just count 7 from the point in which it was easy to count 7 in the grid. So usually these grids give you those 2 points easily. You see? Like, for example, I could have counted 7 here. 2, 4, 6, 7. So this shows that my line is not that parallel. This should be a little better, I guess. Okay, yeah. So I shifted 7, okay? Yes?
I had this question that every time there's like a extra cost, the professor moves the lines down, but when there's like a lower cost, they move it up. I don't get why they do that. Because then if you move it up, wouldn't the price of it be higher? So that's like a higher cost.
What happens for the consumers when the price is higher? They consume more or less? Less. So it makes sense that if there is an extra cost and the price is higher, the demand is going to go down. Okay? Okay. We are going to go over the quantity demanded going down later on. But like in general, prices up, that shifts the demand. Okay? Okay. So here, we move the demand down. And now we need to know what is the total surplus after the socially optimal tax is implemented. What happened with this tax being implemented? Yes, question?
If we had, for example, positive externality, would we move the demand curve up?
If you have a positive externality, yes, you will move the demand curve up. Okay? Okay. So, what happens with a tax? With a tax, this part of the tax goes to the government, right? This is what is called the tax revenue. And this is what we call the dead weight loss, okay? So before, in a market that is in equilibrium with no externalities, what is my total surplus? Is the total surplus of the consumer here and the total surplus of the producer. So this will be my total surplus. But now with the externality and the tax, we have that the government takes this tax revenue to redistribute it, and the society loses this much, the dead weight loss, okay? So my total surplus is going to be this triangle here and this triangle here, okay? So how do we calculate this? First of all, let's calculate the total surplus, okay? Before the tax. So we need to calculate the distance between this point and this point times the quantities, the optimal quantities divided by 2. this point is 17 here, this point is 3 here, and my optimal quantities are 12. Okay? So I have 17 minus 3 times 12 divided by 2, okay? That is this total surplus here. And this is equal to 84. Yes. Okay. Now, we need to subtract the tax revenue and the deadweight loss from this total surplus, okay? So the tax revenue is very easy because that is 6, okay, times 7. The quantities here times the amount of the tax, okay? We know that tax revenue is tax times quantities, and that is 7 times 6, okay? And that number is 42, okay? Now, the area of the deadweight loss is from here to here is 6, because I had 6 here and 12. So this is 6 here, okay, times the size of the tax, okay? 7 times 6 divided by 2. And this is equal to 21. So I will have 84 minus 63. Where does 63 come from? 42 plus 21. This is equal to 21. And the answer is A. You don't need this. There is going to be a video of this review online, so you can just like go. We will send the link. Yes, because this is asking for what is the total surplus after the, or either you find the total surplus to get the answer, or you just find the areas of these triangles here. Yeah, that's fine. She's saying that she just found the areas of these triangles. That's fine. The reason I do it all the way is because I want you to know how to calculate the total surplus, how to calculate the tax revenue, and how to calculate the deadweight loss, okay? But just finding the areas of these triangles is fine, okay? And it's even easier in this case because you have the graphs, so you just see it. I just wanted to go over the whole thing for the sake of other type of questions that you could get, okay?
In the textbook in Chapter 8, it says that when there's a tax, total surplus is equal to the sum of these.
Can you speak louder? I can't hear you.
Sorry. In the textbook in Chapter 8, it says that when there's a tax, total surplus equals consumer surplus plus producer surplus and tax revenue.
Okay.
So I'm not sure why we didn't add tax revenue when there's a tax, because isn't that included in total surplus?
What is the total surplus after the socially optimal tax is implemented? Well, the thing is that in this case, because the optimal tax is to offset the negative externality, it doesn't really goes to, the government has to do something with it, and it's not like the tax revenue in a regular tax. I think that is the reason why you don't put these three together in this specific case, because it's to offset the social effect of the externality. If this were only the government imposes a tax of 7 on this market without the effect of the externality, that will be the case. So here, as I said, this question is tricky because the externality is affecting the society, and then the government wants to do something to offset that externality, right? In general, a tax that is not related to an externality, the government just imposes the tax, takes the money, right? So you say the total surplus, the total surplus for the society is the government has a part, the consumer has a part, and the producer has a part, right? But here, because this is mentioning an externality, the government needs to offset that externality. So the government doesn't take that revenue for the society. You see what I mean? It's because, so this question is easy to solve because it's graphically just like a tax, but conceptually this tax is offsetting something negative that was happening, okay? Yes?
Is another way to calculate the total surplus be the area of the new shift, so the area below the new demand curve, but above the surplus?
Is there a way to calculate the...
Because I got 21 by calculating the area under the...
By calculating this and this?
No, that and the one right above it.
And this one?
Yeah.
Well, because graphically this is the case, you are fine, but that's not the right way to do it because this is part of the tax revenue, okay? So this is not part of the consumer surplus. So you were lucky that graphically those triangles were the same, but I wouldn't risk it doing it this way because those triangles might not be the same in a different case. Okay? Okay. So now, this is very easy because this is how much tax revenue is generated by a 7 per unit tax. And we already did that in the past question. So what is the tax revenue of a 7 per unit tax? The amount of the tax times the quantities, which are 6. So it's 7 times 6, which is 42, and the answer is B. Okay? Good? So that's why I went over how to calculate the tax revenue before, because sometimes you get asked all those questions later, not only calculating the triangles of the consumer surplus. Yes?
The last question.
The last question.
Get the 21 in this case. That's maybe a little confusion.
7 times 6 is 42.
Right.
Divided by 2 because it's the area of a triangle.
Okay.
That is 21. Okay? Good. So he asked, how did I get the 21 in this case for the deadweight loss? And what I'm saying is that this is the area of a triangle. So is the base is the amount of the tax, and the height is the amount of the quantity. So it's 7 times 6, but this is a triangle. So the area of a triangle is base times height divided by 2, okay? Okay, so this is another topic that you usually get in this class, and is all about opportunity cost, comparative advantage, and absolute advantage. So let's go over all those concepts first, and then we solve the question. So we clarify things here. So the opportunity cost is what you give up to get something else, okay? In cases like this of production is how much you give up of the production of one good to produce the other good, right? Because you have limited resources in general. In this case, the resources are like your land and your allocation of time. So because you don't have infinite time, then you have to allocate time doing the production of meat in this case and the production of potatoes. But to produce meat, you need to give up the production of potatoes a little bit. So that is what we call opportunity cost, okay? Absolute advantage in the production of a good is based on what? Yes, and how do you produce? What does that mean? She's saying it's based on how do you produce. You produce using inputs, right? So you have absolute advantage when you need less inputs than someone else or than some other country to produce something, right? That is your absolute advantage. You look, so for absolute advantage, you look at inputs. In this case, my inputs are hours, okay? Labor hours. For comparative advantage, you look at opportunity cost, right? Meaning, compared to my competitor or compared to the farmer or to the rancher in this case, what is my opportunity cost of producing meat or of producing potatoes, right? Do I have to give up more potatoes than him to produce meat or the other way around? When you compare those opportunity costs, you get the answer for the comparative advantage of one or the other, okay? So let's answer the first question, and then the second question is going to ask us about absolute advantage, comparative advantage, and opportunity cost, and we will just calculate them all, okay? So here, refer to this table. Assume that the farmer and the rancher each have 24 labor hours available, fine. Each person divides his time equally between the production of meat and potatoes. Then the production is. So this says pounds produced in 24 hours, okay? So this person, the farmer produces 3 pounds in 24 hours and 3 pounds of meat and 12 pounds of potatoes. So how do you do this? You say, if they divide the time equally between the production of meat and potatoes. This means that the farmer is going to spend 12 hours producing meat and 12 hours producing potatoes, right? And here it says, it takes 8 hours to produce 1 pound of meat, okay? And 2 hours to produce 2 pounds of potatoes. But there is an easier way to do this, and it's just you divide this in, so half of the time this person produces, if this person uses half of the time to produce meat, this person will produce 1.5 pounds of meat and 6 pounds of potatoes, and the other person will produce 4 pounds of meat and 2 pounds of potatoes. So the amounts here are 6.5 meat and 5.5 and 8 pounds of potatoes, okay? So the answer here is B. 5.5 pounds of meat and 8 pounds of potatoes. You just divided this part. So this is, it looks tricky because you think that you have like to use this part of the graph, but then since you have the amount produced in 24 hours, you just like, okay, this is produced in 24 hours, in half of the time is half of the amount, etc. Okay? Now, a more difficult question. This is the next one. Oh,
Is it acceptable if you can add both the farmer and rancher together and then divide by 2, or?
is it acceptable? Is it acceptable if you can add what? Add these 2 and divide it by 2? Yeah. Yeah, you can do it that way too.
Why did you not use labor hours and you used 24 hours instead?
Because this is saying that they use 24 hours are available and they divide the day half and half. And this is telling me that like when they use 24 hours to produce this thing only, they produce this. To produce this thing only, they produce this. So I can just like either do what he said and is just add everything up and divide it in 1 day, right? Or divide this in half, because that will be 12 hours to this in half, 12 hours, this in half, and just add them up, okay? Good. Okay, so the next question. Which of the following statements is correct? And all these statements are related to absolute advantage and comparative advantage. So before going through them, let's just calculate absolute and comparative advantage for both of them, so we will have the answer right away. Because you might have situations in which you have options like this, in which you can just like cross off the ones that don't work, or in which you have to calculate numbers for opportunity cost, etc. So it's better if we do it, if we calculate it all. So let's see, where can I do this? Okay. Also, sometimes you don't have questions with a table, but a story in which they tell you these numbers on a paragraph, right? And you have to basically put those things into a graph or into a table like this, okay? So let's see if it can fit in here. So my farmer here, in a time of 24 hours, can produce this, right? If the farmer uses all the time producing meat, will produce 3 pounds of meat. If the farmer uses all the time producing potatoes, will produce 12 pounds of potatoes. The rancher will have a graph like this. Sometimes what you get instead of a table like this is a graph like this, okay? So that's why I'm also showing it graphically. So then, let's talk about absolute advantage. So what do you look for in absolute advantage? As I said, inputs, okay? What are the inputs? Labor hours needed to make 1 pound, okay? So if we compare the inputs needed for the farmer versus the rancher to produce meat, who has an absolute advantage? The rancher. The rancher needs only 3 hours to produce 1 pound of meat versus the farmer that needs 8 hours, okay? So the rancher needs less input to produce meat. Whereas in the case of potatoes, the farmer needs 2 hours to produce potatoes versus the rancher that needs 6 hours to produce potatoes. So the farmer has an absolute advantage in the production of potatoes. So again, when the question is about absolute advantage, you look at the inputs needed to produce the good, okay? Everyone with me? Good. Now, so now we know that the farmer has an absolute advantage in the production of potatoes. So this one works for now. And the farmer has Okay, and this one could work for now, that the farmer has both absolute and comparative advantage in the production of potatoes. But we need to check the comparative advantage to see if it's one of these ones. So this P or C? No, because the farmer doesn't have an absolute advantage in the production of meat, okay? By looking at this, at the inputs needed to produce the good. Everyone with me? Okay, so now, how do you calculate how do you get the comparative advantage? By looking at the opportunity cost. How do you calculate the opportunity cost? What you have to give up to produce the other good. So for the farmer, the opportunity cost of meat is equal to what? 12/3. Because it's that to produce 12, the farmer has to give up 12 pounds of potatoes to produce 3 pounds of meat, okay? So the opportunity cost of producing meat for the farmer is 4, okay? Now, the opportunity cost of producing meat for the rancher is 4/8, right? And this is equal to 1/2. So what do we see here? That what the farmer has to give up to produce meat is higher than what the rancher has to give up to produce meat. So who has a comparative advantage on meat? The farmer has to give up 4 pounds of potatoes in order to produce 8 pounds of meat, right? So it's like each pound of meat costs half pound of potatoes, basically. Each pound of meat costs 4 pounds of potatoes, okay? Good? Now the opportunity cost of the other good is the opposite of this one. So opportunity cost of potatoes is equal to 1/4. Opportunity cost of potatoes in this case is equal to 2. So now for the farmer, it is cheaper to produce potatoes in terms of meat than for the rancher to produce potatoes in terms of meat. Because the rancher needs to give up 2 pounds of meat to produce 1 pound of potatoes versus the farmer that needs to give up only 1/4 of meat to produce 1 pound of potatoes. So the farmer has comparative advantage also in the production of potatoes, okay? So my answer is D. Is everyone with me here? So let's recap here. Absolute advantage, you look at the inputs. You look at the labor hours or the land needed. It depends on the question. Usually it's labor hours needed to produce the good, okay? In this case, you compare 8 versus 3, 2 versus 6, and you have your answer. Now, comparative advantage is comparing what each producer has to give up to produce each good, okay? So first of all, what did I do? I checked the opportunity cost for each of them to produce meat, meaning how much potatoes each of them has to give up to produce meat. In this case, in the farmer's case has to give up 12 pounds of potatoes to produce 3 pounds of meat, okay? You just follow this whole thing, or the graphs, because sometimes you will get the graphs in your question. And this means that each pound of meat cost the farmer 4 pounds of potatoes. In this case, the rancher needs to give up 4 pounds of potatoes to produce 8 pounds of meat. So it costs the farmer only 1/2 pound of potatoes to produce meat. Rancher. Did I say farmer? The rancher. Okay? So then, what happens is that the farmer has to give up more potatoes than the rancher to produce 1 pound of meat. Meaning that the rancher has a comparative advantage in the production of meat, okay? And it's the other way around for the production of potatoes. The farmer has to give up only 1/4 pound of meat to produce 1 pound of potatoes versus the rancher that has to give up 2 pounds of meat to produce 1 pound of potatoes. This can be calculated, once you calculate the opportunity cost of one good, the opportunity cost of the other good is the inverse, okay? Everyone with me? Good. Okay. Now. Question 7. A cable television broadcast of a movie is. So what happens with cable television? Cable is something that you have to pay for. Some people don't get it because some people don't pay for it, okay? When you have a good that you have to pay for, it is a good that is excludable, right? You, in general, don't have to pay a ticket to go to Central Park. So Central Park is not excludable. Central Park is a public good that is not excludable. So cable television is excludable. So we have two options here. Now, but is cable television rival? If you use cable television, you pay for cable television. If you use it, are you preventing other people from using it? Not really. So it's not, so when a good is rival, is that the use of that good, if you use that good, you are preventing other people for using it, okay?
Could you give some examples of the rival goods?
For example, a lake, right? If you go to a small lake and you want to swim in that lake, okay? If you start, or a public pool, you start using one lane, it is a public pool, it's not excludable, but when you start using that lane, you are preventing other people for using that lane. Whereas public lights, if you go and that light illuminates your path, you're not preventing other people for being illuminated by that light, okay? Is that clear? Good. So the answer here is B, is not rival. Good. Clear? Clear the other examples of public goods, not rival, etc.? Okay. Another question? Yes? Be loud, please.
Yeah, can you just explain excludable and non-excludable again?
Can you also explain excludable and non-excludable? Okay. Ay, oops. Okay. Why do you think that cable is excludable? Because if you don't pay for it, you don't get it. Like when you want to see Game of Thrones and then you see that you have to sign up for it, and then you sign up for it for 1 month because like, okay, that is a good that is excludable. You don't need, whereas Central Park is not excludable, right? You don't have to, other people, the fact that you go there doesn't, sorry, you don't have to pay for it, so that doesn't exclude other people for going there, okay? Except like, I mean, some people that don't live here, etc., but in general, that's the case, okay? So usually goods, you use the term of excludable for public goods that you don't have to pay versus private goods. You know, in general, private goods are excludable, public goods are not, okay? But there are some public goods that are rival versus some other public goods that are not, okay? Good? Okay, now, willingness to pay. This willingness to pay is the basics of a demand function, right? So here, consider the town of Anywhere with only 3 residents, Mary, Bill, and Tricia, the three residents are trying to determine how large in acres they should build the public park. The table below shows each resident willingness to pay for each acre of the park. Okay, so we have that for acre 1, this, each guy is willing to pay this much, etc. And then the question is, suppose the cost of building the park is 33 per acre. Okay? Now, how many acres maximize total surplus from the park in anywhere? What does it mean maximizing total surplus? That the equilibrium price, okay, or like the supply price is equal to the demand function at some point. Meaning that a price in which your willingness to pay is higher than this price, okay? So, what is it that you do here? Willingness to pay is a demand function, right? You have a price of 33 here. You have to find the point in which they almost meet, so you maximize the surplus, okay? So how do we do this? We have to check that the price that they are willing to pay is not lower than 33, so they are able to afford it, okay? So, for the first acre, 14 plus 18 plus 30 is higher than 33, right? I mean, already 18 plus 30 is higher than 33. Now, the second acre, 10 plus 14 plus 26 is also higher than 33. The third acre, 22 plus 10, 32 plus 6, 38. This is higher than 33. But then 18 plus 4 is 22 plus 6 is 28. This is not higher than 33, okay? So my demand is 3 acres, okay? Because that is the amount that they are willing to pay that is exactly higher than the cost. Yes?
Willingness to pay again? Because I...
Define willingness to pay?
Yeah, I kind of...
Okay, so each of these people are willing to pay for each acre a certain amount of money, okay? They want to build the park together, they get together, okay, and they pool the money for each acre, right? So, I'm the person who is offering to build the park, and I'm like, each acre is 33, so let's see. So they tell me, well, between the three of us, we are willing to pay for the first acre this much, okay? And I see like, oh, okay, that's higher than how much it costs, so we can build that first acre. So then say like, okay, let's see if we can build a second acre. For a second acre, we are willing to pay this much, okay? Within the three of them. We put that money together, we check that money together, and I said like, oh, okay, if you guys put your money together, that is higher than my price, so we are good. We can build a 2 acres park. Then for the third acre, they again say 22 plus 10, 32 plus 6, 38, okay? That's still higher than my price. I'm like, okay, yeah, we can build a 3 acre park. Then I say like, okay, let's see if we can go bigger. And they are like, okay, for the 4th acre, we are only willing to pay 10 plus 18, which is 28. That is lower than my price per acre. So I'm like, okay, I don't go farther than that, right? I'm the producer, right? So what we're finding there is the equilibrium between demand and supply, because demand is the willingness to pay. Demand is representing how much the consumer is willing to pay per quantity, right? Okay, so as I said, we get together, I'm the producer, we check and we get to a point in which, okay, for 3 acres, we can do business. They end up paying 33, okay, and they have a consumer surplus because in all these cases, their willingness to pay is higher than my price. But they don't go below because it's lower than my price and I'm not willing to build at a lower price. Okay? Is everyone with me? Yes.
Just to confirm, like total maximizing total surplus, it's like above the equilibrium price, right? In a sense, the area.
No, the total so this is the consumer surplus and this is the producer surplus, right? So the total surplus is all this area. Here, they are not giving me a supply function. The supply function here is a price of 33, right? Sorry. The supply function here is a price of 33. So the total surplus here will be only the consumer surplus because they are not telling me anything about my production function, right? Or my supply function. So in this case, you think about this as the difference between the cost or the equilibrium price and my willingness to pay, okay? And this will be the total surplus. Clear? Okay. So don't forget, total surplus is usually consumer surplus plus producer surplus, which is this. Oops. Okay, this whole thing. But depending on the cases, you can have, you don't have a supply function, but you have an equilibrium price, so you just work with it. Okay? Yes?
So if they ask for the consumer surplus, it would
So
be
if they ask for,
the consumer surplus, it would just be the same thing, right?
if they ask for a consumer surplus here, yeah. It will be the same thing. Okay, 8 more to go for me. Nine. Before the flu season, we already talked about this, so you guys probably will have an answer for it. Before the flu season begins, Jeremy gets a flu shot. As a result, Jeremy and several of his friends and relatives avoid the flu shot for the entire flu season. It will make sense to argue that A, flu shots provide a positive externality and that flu shots should be subsidized, okay? We already talked about it and we said that flu shots provide a positive externality because if you get it, then you reduce the likelihood of other people getting it, okay? Good. So that is a positive externality. B, if flu shots are not subsidized, then the number of people getting flu shots will be smaller than the socially optimal number. So what happens in general with an externality is that if it is positive, right, and the good that is producing the externality is too expensive, for example, but you want the externality in the society, the government subsidizes it, okay? That is usually the case with things like medicine, okay? So here, if the government, if the flu shots are not subsidized, then the optimal people, the optimal social number of people that will get the flu shots is smaller, right? And that is not what we want. So this is also true. B, if flu shots are not subsidized, the number of people getting the flu shot will go down or will be smaller. C, the externality generated by flu shots is more like the externality generated by education than the externality generated by pollution. Here we are facing a positive externality versus a negative externality. What is the externality of pollution? That you can have a lung disease or a respiratory disease, that you are inhaling chemicals, etc., okay? So it is, if you have a farm that is producing a lot of pollution next to your house, that farm is giving giving you a negative externality, okay? And whereas education is a positive externality because the more educated you get, you are surrounded by other people, you can give them ideas, etc., so that is a positive externality, okay? So they compare the flu shots with a positive externality of education versus a negative externality of pollution. And we already said that flu shots are a positive externality, so this is also true, okay? So our answer is all of the above are correct, okay? Good? Now, 10. Okay, this, I like these questions because you go over a lot of things with them. Equilibrium quantity must decrease when demand, okay? So we have the following. We have demand and supply, prices and quantities. This is saying if demand increases, okay, what is an increase in the demand? A shift of the demand, right? Up. If demand increases and supply does not change, now they say also when demand does not change but supply decreases, okay, and when both the demand, okay, demand 1, demand 2, supply 1, supply 2. Okay, so first part of this. Equilibrium quantity must decrease when demand increases and supply does not change. That's not the case because when demand increases and supply does not change, equilibrium quantity increases. Okay? Good? Now, this is not the case, but let's see what happens in the rest of the sentence, okay? For the sake of the review. When demand does not change and supply increases, demand stays, supply decreases. Supply 1, supply 2. Demand stays the same, supply decreases, okay? In that case, yes, the quantity decreases, but not in the two cases at the same time, okay? So this is not an answer. Okay. And the other one is, and when both demand and supply decrease. Demand decreases, goes down here. Supply decreases, goes like this, okay? Shifts to the left. So quantity decreases, okay? In these both cases, yes, quantity decreases, but in this one, not. And all of them are in the same sentence, so that's not the case, okay? I'm going over all of this because you can get a question on where they ask you that and they show you this graph, or they only show you this, so you need to know how to move demand and supply function, okay? Okay. Equilibrium quantity must decrease when demand increases. So demand increases. Supply does not change. Okay, so this is not the case either, right? So we can also cross this one out. Now, I'm not going over the other ones because they are very similar, but let's go over C. Equilibrium quantity must decrease when demand decreases. Supply, demand. Okay, demand decreases. And supply does not change. Okay, this one, equilibrium quantity decreases, moves to the left from quantity 1 to quantity 2 that is smaller. Okay, so this check. When demand does not change, demand, supply. When demand does not change, demand does not change. And supply increases. If supply increases, supply moves to the right, okay? What happens here? quantity of equilibrium goes from here to here. Quantity 1, quantity 2. This is bigger than this, okay? So quantity increases, okay? So this is not the case, right? We are left with D. Demand decreases, yes. Demand 1, supply 1, demand decreases, okay, good. That's the first part. Yes, equilibrium quantity decreases when demand decreases. Supply does not change, as I said. When demand does not change, demand stays the same, and supply decreases, quantity also decreases, okay? Quantity 1, quantity 2. So we are good there. And then when both demand and supply decrease. Demand, supply, if they both decrease, they both move to the left, quantities decrease, okay? So the answer is D. Good? I'm taking a lot of time to answer this question, so you know how to draw these things and put them in your mind, but like maybe in an exam you don't need to draw them all to know what that happens, and you can just like, okay, if demand increases, that doesn't count, so I cross it off. If demand increases, that doesn't count, I cross it off. If demand increases and supply does not change, sorry, okay? So you can just like cross off things without doing all of this. Okay, now, this is also an important question because you get many of these. So you have two graphs here. They are basically the same. They both illustrate a $2 tax placed on the market. But what is the difference between these two? Elasticity in the supply or the demand function? In the supply function, okay? So I have a trick that I always use in my class, and I think it has always worked, and is that when you think about a graph that is inelastic, it looks like this, okay? Like an eye, okay? Inelastic. If you think about a graph that is elastic, perfectly elastic, it looks like this. If you elastic, okay? If you remember this, I guarantee you that you always think E for elastic, because it has the line here, I for inelastic, okay? And it will, and then when you compare these two, okay, this one looks more than this one, so this one is relatively more elastic than this one, okay? No? Yeah. Isn't this one is flatter than this one, right? Yeah? Okay, so the flatter it is, the closer it is to a graph that looks like an E. The steeper it is, the closer it is to a graph that looks like an I, okay? That is always the way I have thought about it, about this, and I tell it to my students, and it's usually a trick that works. You probably just need to practice E, I, E, I. Okay, so now, besides this trick, what is elasticity? Elasticity is the measure of the response to a change in prices, okay? On the consumer side, meaning on the demand side, elasticity tells me if there is a change in prices, if the demand is very elastic, it means that the consumers are going to change the quantities a lot, okay? Because they respond a lot to a change in prices. If the demand is very inelastic, that means that the consumers don't respond that much to a change in prices, okay? What is the inelastic demand? Okay, like food, like like food. You have to eat all the time. Maybe you will change certain things that you eat, but in general, if you think about food prices go up, the amount that you consume won't go up that much because you still need to feed yourself, okay? So the demand for food in general is more inelastic because you don't respond in quantities that much. Of course, the demand for salmon might be elastic because you might just like not consume salmon and consume other things. But in general, food is inelastic, okay? Now, elastic is when something changes, for example, salmon, right? If salmon prices go up, then you are like, oh, okay, I'm just like not consuming that much and reducing my quantities. That one is very elastic, okay? And I think there are examples in the book in which they say like the more specific you go on the group, like food, then salmon, then you move from very inelastic to more elastic demand, okay? Okay, good. So since elasticity is a measure of the responsiveness to prices, right? This means that when prices changes, quantities are gonna change, okay? If an elasticity is, the formula is the other way, right? Yeah. Q. Right? So this is the formula for elasticity. If a function, either demand or supply, is very elastic, what happens? If there is a change in prices here, there is going to be a change in prices here that offset the change, a change in quantities here that offsets the change in prices, right? Okay. So now, having said this, what can you see here? This one is more elastic. What is a tax? A tax is a change in prices, right? Okay, so the effect of a tax affects the quantities given the elasticity of the supply or the demand, okay? So in general, when a government wants to affect a market with a tax, the government has to think of the elasticity of the supply or the demand of that market. Because if the supply or the demand is very elastic, then the change in quantities might be too much that they are affecting the market a lot. And the deadweight loss is going to be bigger, right? As you can see here, the tax is 2, but the change in quantities is a lot. Is 1.7 almost, right? Versus here, that the supply is relatively inelastic, and the change in quantities is only 1 due to a change in prices of 2, okay? So, the answer here is A. Well, it's not A. I'm going to read them. When demand is relatively inelastic, the deadweight loss of a tax is smaller than when demand is relatively elastic. We cannot really see that from here because the demand functions are the same, right? Like very similar. And that's not the case. So then B, when demand is relatively elastic, the deadweight loss, when demand is relatively elastic, the deadweight loss of a tax is larger than when demand is relatively inelastic. Again, the difference here is not in demand, it's in supply. So no. C, when supply is relatively inelastic, which is this case, compared to this one, because this one is closer to the E, the deadweight loss of attacks, which is this, what is the deadweight loss? The amount of the tax times the change in quantity due to the tax divided by 2, the amount of the tax times the change in quantity divided by 2. When supply is relatively inelastic, the deadweight loss of a tax is smaller than when supply is relatively elastic, okay? Which is exactly this case, okay? The deadweight loss of a tax here is smaller than this one because what? Because the response to the change in prices when supply is elastic is bigger than the response here, okay? Is everyone with me? So always think about elasticity as the response to the change in prices, either from the supply side or from the demand side. And you will be fine. And remember the E and I, and you will be fine thinking about elasticities, okay? Sometimes it's funny when I say this because then what is my job? But a lot of the things in economics are common sense. So yeah, what is if your response to changing prices is higher, then you will consume less, so your quantities will change, okay? C. Good. Now we are gonna go over questions of supply and demand, similar to the ones that we went over at the beginning, the graphic ones, but with equations, okay? Which is more fun, I think. Okay, so scenario international trade. P, this should be P of the demand, I'm sorry. So this is demand and supply. Price of the demand is equal to 100 minus 3 quantity demanded, and price of the supply is equal to 20 plus 2Q. And that's the domestic supply in a small country. The world price for a backpack is 70, okay? Now, what is the domestic equilibrium price if there is no free trade? So domestic equilibrium price is just making demand and supply equal, yes?
What makes D wrong? Does that make D
Question about last one. What?
Previous question. What makes number D wrong? Like choice D wrong?
Can you go back, Daniel, please? Number B. Because it is talking about demand being relatively elastic or not, and you don't have demands in the graph to compare because they are both the same, right? At D, when supply is relatively elastic, when supply is relatively elastic, which is this case, the deadweight loss of a tax is larger than when supply is relatively. Okay, where I don't see your question. What makes D wrong? When supply is relatively inelastic, which is this case, the deadweight loss of a tax is larger than when supply is relatively inelastic, which is this case. When supply is relatively inelastic. Panel A, okay, yes, you're right, because panel A is referring to what panel A illustrates of the following statements, which is comparing one to the other one, okay? Good, thank you. Okay, question 12. Okay, so we have to make, this question is asking me, what is the domestic equilibrium price if there is no free trade? So the domestic equilibrium price is just, you just make supply and demand function equal, okay? So here, demand equal to supply, then your equilibrium becomes the, your equilibrium and your your quantities and your prices becomes the equilibrium price and quantities. So you just do 100 minus 3 quantities of equilibrium equal 20 plus 2 quantities of equilibrium. Then you take this 20 to this side, you put together the things that you have to put together. So quantities are together here, 3Q plus 2Q, okay? This is 80, this is 5Q, then my quantities of equilibrium are 16. Good? Okay? So what did I do? I make supply and demand equal, then I put together the quantities, and I put together the numbers, and then I just find what the equilibrium quantity is, okay? So the equilibrium quantity is 16, but what they are asking me is the equilibrium price. So, what do? I put the equilibrium quantity in either the supply and the demand function. I always think that it's easier to add than to subtract, so I put it in the supply function, 20 plus 2 times 16, okay? And this is equal to 20 plus 32. And this is equal to 52, which is my equilibrium price, okay? So, yes, the answer is B. The equilibrium price is 52. Clear? Good. Now, question 13. What can I save from this? Okay. So, we said that quantities are 16, right? Okay. So, usually for these questions with trade, drawing a graph is good for you to like figure out what's going on. So you have supply, demand, prices, quantities. You have your equilibrium price that is 52, and they tell you that now they allow trade, and they told you that the world price was 70. So when they allow trade, now the price becomes this one, okay? Trade is similar to having a price floor, right? But here, instead of surplus, you have your surplus becomes exports, exactly. Why? Because the quantity demanded is smaller than the quantity supplied, but they have the rest of the world to offer what they have, so they just export these quantities. So what do? You put the price of 70 in the demand function and in the supply function, and you find the quantity supplied versus the quantity demanded, and this gives you the exports. Okay? So we are going to make that calculation, which is 70 equal 100 minus 3 quantity demanded. This is equal to, I can move this 3 quantity demanded here to be positive, and then 100 minus 70 is equal to 30. So then quantity demanded is 30 divided by 3, which is equal to 10, okay? So this quantity here is equal to 10, okay? And now the quantity supplied is 70, again, the price, the world price, equal to 100, 20, I'm sorry, 20 plus 2 quantity supplied, which is equal to 50. I move this 20 to the other side to subtract it from 70, equal to 2QS. 50 divided by 2 is equal to the quantity supplied. This is equal to 25, okay? 25. So the exports are the quantity supplied minus the quantity demanded, 15, okay? Yes. So answer is B, 15, okay? Good. Every time you want to find these two numbers, you make, so every time you want to find the quantity demanded or the quantity supplied given a price, either in a domestic market with a price ceiling or a price floor, or in a market with international trade with a world price, you just put the price in the supply function and in the demand function and find the quantities associated with it. Okay? Yes?
Is it exports because it's on the x-axis, or why is it exports?
It's exports because supply is more than the quantity demanded. So what you have in your country to offer is more than what they are demanded, so you sell it outside your country. That's why it's exports. It will be imports if the quantity demanded is higher than the quantity supplied, so you need to get it from the rest of the world, okay? There is a case with imports here, yes?
Would that be when the world price is lower than the...
Exactly. When the world price is lower than the equilibrium price, then what happens? You have a shortage, basically, internally. So you need from the rest of the world to sell you the stuff, okay? Okay, question 14 now. Do I need, oh, okay. Okay, so when I have refer to the scenario international trade, the increase in total surplus because of trade is. So what happens in the domestic market? What is the total surplus? The consumer surplus plus the producer surplus, right? This is the total surplus when the market doesn't open to trade. When you open to trade, then you get all of this from the rest of the world, right? Because you get to sell, the producers in your country get to sell all these quantities here. And they get this price. So they get all of this, right? So the change in the total surplus is, am I reading this correctly? Total increase in total surplus, yeah, okay. Okay, yes. So, what is this? How do you measure this? The height of the triangle times the base of the triangle divided by 2, right? So what is the base? Is the exports, 15. Times what? The difference between the world price and the equilibrium price, okay? This is 70 minus 52, okay? All of that divided by 2. That is equal to 15 times 18 divided by 2, which is equal to 135, okay? So sometimes even when you get, when the question has only equations, it's a good idea to draw the things, right? Because you need to know like which area do you have to calculate something. Yes?
How did you get 15 in this case?
How did I get 15? Oh, because it's the exports. So the quantity that they exported is the quantity that they get this money for, okay? Right? So they get the difference in this price for all the quantities that they export, right? So that is the additional surplus. Yes?
Because it says increase in total surplus, aren't you supposed to subtract the two total surpluses, like the international trade surplus minus the domestic total surplus? Because it's asking for an increase in total surplus.
No, but because the increase in total surplus is this triangle here. You don't know the rest of the world market. You only know like this the increase in total surplus in this market with international trade. So is this triangle here? This is the extra part. Yes? This one? No. I was telling you in the domestic market, this is the total surplus, right? This red big triangle here. But the increase in the total surplus is adding the exports, okay, to this. So what is adding the exports? This thing here. Why is this total surplus? Because for the producers, they could be selling at these prices, okay? And at this price of 52 internally, but they are actually selling all of these at 70, I'm sorry, okay? So they get that differential money, right?
So you don't use the top one?
No, I only use this green triangle here. This is the extra. So again, let me draw it again for you. So in a domestic market, what is the total surplus? This, okay? This triangle here, okay? When there is international trade, right, in this case exports, you get this new price, right? So then, this new triangle becomes an extra thing for the society in the country that is exporting, okay? So this is the increase in total surplus for this country, right? When they open to trade. So you have to find the area of that triangle. There was a question in the back.
Is that considered producer surplus?
Is that what?
Considered producer surplus?
That, yeah, this is mostly producer surplus because the producer is the one that is selling those quantities exported. Okay? Yeah. Yes.
Is domestic price impacted by the world price in this case?
Usually, I mean, in reality, it's more complicated than that because when you have like, it's not that I don't know. Oranges, when the oranges from Mexico come, then all the oranges are the same price, and no, it's like oranges here have certain price, and Mexico oranges has certain price. Here, the international price is higher. That's why you export, but domestically you pay cheaper. Yes, like everyone in the country demands up to here, right? They pay this, but from here to here. The producers sell all of this to the. So actually, what happens in the international trade is that now the producers get all of this. You see what I mean? Because the producers are not selling this in the domestic market. They are selling they sell all of this in the domestic market at a price of 52, and all of this in the outside market. Okay. Okay, question 16. I mean, I say in reality it's more complicated than that because sometimes the countries subsidize the domestic products so they are cheaper, or they, besides the world price, they put a tariff to protect the internal market. So there are a lot of things going on with international trade and trade agreements, etc., than just this graph, but this is like a start. Yes?
So in the graph, will the consumer surplus stay the same in that previous graph?
No, the
No, it
consumer
just-
surplus will change because now they will be consuming only this much, you know? This, now the producer surplus gets it because it's selling it to the outside, okay? Okay, so question 16. Same supplies and same demand. The world price for backpacks is 70, referred to because of the Great Recession, the world price falls to 40. So now what we have here, we just do the same but with a different scenario. Sort of, we have this is 52. Now the world price goes here to 40. Okay. So we need to check what happens with exports or imports, etc. So what is going to happen now? Are we going to export or import? Import, right? Yes? Okay, good. And what do we have to do? We have to, since the price changed, we have to put the price in the supply function, put the price in the demand function, and find the imports, okay? So this is again 40 equals 100 minus 3Q. 40 equals 20 plus 2Q. This Q is equal to 20, and this Q is equal to 10. Okay, so imports are now 10. Okay, the difference between the quantity supplied here, here the quantity supplied is 10 and the quantity demanded is 20. So my imports are going to be 10. Okay, so the answer is B. The country imports 10 units and consumer surplus rises. Why does consumer surplus rises? Because of the same thing that you were asking before. Now, the consumer has a higher willingness to pay for a lower price. So they get this much that they weren't getting before, right? And all of this. Okay? Because they are paying less than before. Okay? Clear? Good. Next question, 16. So now given that world price is 40, the government decides to protect domestic producers by imposing a tariff of 6. As a result, so what is a tariff of 6? Now it's a change in prices. Now the world price becomes 46 for you because you have to pay extra for the goods that are coming from outside. Right? So you just do exactly the same thing that you did before. Now price, instead of being 40, is 46, and you make the calculation here, and this is telling you that okay, 3Q equals 100 minus 46. This is 54 divided, this is 54. 54 equal to 3Q. Q is equal to 18, which is 18, which is equal to 54 divided by 3. Good. And now here we have 46 minus 20 equal 26 equal to Q. Yes, so now 26 divided by 2 is equal to 13, which is equal to Q, right? And the difference between 13 and 18 is 5. 5. You now import 5 units. And before you were importing 10, so the imports decline by 10 units and consumer surplus falls. Why? Because the consumer, why does it fall? Because they are paying more than before, okay? The answer is what? Imports decline by units and producer surplus rises. Okay, it's the same. Now the producers are getting paid more than before because they are being protected by a tariff, right? Let me show you this to you. So this was how it was, and the producer surplus was being this, okay? Now they are protected and they put the price here. So the producer surplus increases and the quantity imported is smaller, okay? Good? Okay.